The Cretaceous oceans already had more than enough going on. They were incredibly diverse ecosystems with mosasaurs, plesiosaurs, sharks and ammonites, among other amazing creatures. But scientists have just discovered evidence that suggests that these same oceans contained a creature of legend. A paper published in the journal Science just 3 weeks ago suggests that there may have been something else down there, something with 8 arms, a brain built for problem solving and a body that left almost no trace in the fossil record for over 80 million years. Meet Nanaimoteuthis haggarti, and it is being coined the Cretaceous Kraken. The fossils come from roughly 85 million year old rocks on Vancouver Island, Canada, with additional specimens from Hokkaido, Japan. And here's the first thing worth understanding. What they found wasn't a skeleton, because there wasn't one to find. Cephalopods are soft-bodied animals, so they don't preserve well, which is why our fossil record of them is so patchy compared to the reptiles and fish that we usually talk about. What they did find, however, were beaks, hard chitinous mouthparts functionally similar to a parrot's beak used by modern octopuses and squids to grip and crush prey. It's not the most glamorous fossil find, nor is it something that you're likely to see as the centerpiece in a museum, but scientifically it's incredible. In cephalopods, beak size scales with overall body size in fairly predictable ways. Measure the beak and you can estimate the size of the animal. The researchers examined 27 fossil beaks in total, the largest specimen being 1.5 times bigger than the beaks of today's giant squid, which is already one of the largest invertebrates alive. That single comparison tells you everything that you need to know about why this find caused such a reaction. Based on beak morphology, this animal was not classified as a vampire squid, which is what earlier descriptions had suggested, but as a cirrate octopus, an animal within the suborder Cirrata, or a finned octopus. That's a meaningful distinction and we'll come back to it later. Right, so the numbers. The research team estimated Nanaimoteuthis haggarti at between 7 and 19 meters in total length. In imperial terms, that's roughly 22 to 62 feet. For a visual reference, 19 meters is about the length of a bowling lane or 2 double-decker buses end to end. Now, that's a wide range, and it's worth being straight about why. The estimates are extrapolated from beak proportions using scaling relationships observed in living octopuses. The conservative end, 7 meters, is well supported and would already make this one of the largest octopuses ever recorded. The upper end of 19 meters is where some researchers have pushed back. Craig McLean, a body size specialist at Duke University, has publicly questioned whether the top estimates may be overreached. So, the honest position is this: somewhere between 7 and 19 meters, probably larger towards the conservative end as the dust settles. And even at the minimum size, it's still a remarkable animal. The giant Pacific octopus, the largest living octopus today, maxes out at around 5 meters. The Nanaimoteuthis haggarti was bigger than this at its worst. This is where the cirrate classification becomes interesting. Modern cirrate octopuses, the finned octopuses, are deep-sea animals. They use their ear-like fins to move through the water column with surprising efficiency, and their webbed arms to trap prey. They're not the jet propulsion hunters most people picture when they think of octopuses or squid. They're slower, more deliberate, and built for deeper water. If Nanaimoteuthis behaved like its modern relatives, it wasn't a sprinting pursuit predator chasing fish through open water. It was probably a deep water hunter using size and those webbed arms to engulf or trap prey rather than pursue it. The beak wear and tear evidence supports a predatory lifestyle. Adult specimens show heavily chipped and cracked beaks, the kind of wear you only get from repeatedly crushing hard material. We're talking bones, shells, possibly crustaceans, fish and other cephalopods. Younger specimens show significantly less wear, suggesting that the animal grew into increasingly heavy-duty diets as they matured. That's a pattern we see in modern large predators too. Asymmetric wear patterns on some specimens have also been flagged as potentially indicating lateralized behavior, essentially a preference for one side of the beak over the other, which in modern animals is associated with more complex neural processing. It's tentative, but it adds to the picture of an animal that was cognitively more sophisticated than most of what shared its oceans. The paper makes a significant claim that Nanaimoteuthis haggarti was likely an apex predator in its environment, potentially competing with mosasaurs for food rather than being prey for them. That's a bold statement and it's worth interrogating properly. At 7 to 19 meters, size alone puts it within the conversation. The largest mosasaurs, Mosasaurus or Tylosaurus, were within the 12 to 17 meter range. A fully grown Nanaimoteuthis at the upper estimates would be well within this bracket, but its size wasn't the whole story. Mosasaurs were fast, visually orientated, air-breathing pursuit predators. The Nanaimoteuthis, if it behaved like modern cirrate octopuses, occupied an entirely different niche. Probably deep water, different prey, different hunting strategy entirely. Direct competition for the same prey in the same space may have been overstated. What the paper is really challenging is the assumption that Cretaceous marine ecosystems were dominated entirely by vertebrates. The argument is that giant invertebrates were significant players too, not the side characters that we've always assumed them to be. They were genuine apex predators within their own right. That's the paradigm shift here, and the part that holds up regardless of where the size debate lands. The fossil record for soft-bodied animals is always going to be incomplete. Cephalopods have been ecologically dominant in the world's oceans for hundreds of millions of years, and we know almost nothing about their history simply because they don't preserve very well. The conditions required for soft tissue fossilization are immensely rare. Most of what lived, swam, hunted and died within the oceans left almost nothing behind. Nanaimoteuthis is a glimpse through a window that we rarely ever get. It tells us that at least some cephalopods reached sizes we hadn't accounted for, and that they were true apex predators, not just prey, and that the Cretaceous ocean had a layer of complexity that we're still trying to understand. The paper was only published a few weeks ago. More specimens may already be in the pipeline, so the size debate will continue and estimates will be refined and our picture of the animal will get sharper. That's how this works, and that is honestly the best part. Nanaimoteuthis haggarti, somewhere between 7 and 19 meters long, heavily armed, cognitively sophisticated potentially, and apparently ruling Cretaceous deep while dinosaurs were getting all the attention on land. The Cretaceous ocean was already one of the most dangerous environments in Earth's history, but as it turns out, we may have been undercounting the dangers within it. As always, if this story develops, and with a paper this fresh it no doubt will, I'll cover it, so make sure you subscribe so you don't miss a thing. I'd also appreciate a like, and please leave a comment telling me what topics you want covered in future videos. But until then, thanks for watching and stay curious.